Okay, welcome to the second part of Applied Handbook 2. And we're going to start looking at measures of location and spread. In this particular video, we're just going to focus on measures of location, what you might better know this as mean, median, and mode. Okay, so three different types of averages. So really this video hopefully isn't anything too new. It is kind of just a reminder of what we do at GCSE, and maybe just for the grouped frequency tables might just be a little bit of a reminder if you forgot how to do that part. So mode is your most common value, median is your middle value. To find that, we have to add 1 to how many pieces of data we've got and divide that by 2. The reason being, if you've got 6 pieces of data, well, it's not your third one that's in the middle, it's your third and fourth value that's in the middle. Okay, so if you did that, 6 plus 1, 7 divided by 2, it's 3.5. So looking for your 3.5 value. So you have to take the middle of the middle in that case. And you mean, you add up all the numbers and then divide by how many there are. So just as a new way of looking at this, we can use x with a line above it like this to represent the mean. And then sigma x is Greek letter here being sigma. Sigma x means add up all the observations, all your data, okay, because sigma means sum of, and then n is just the number of values you have. Okay, so it's useful to know this notation, because you may just get given sigma x in the exam. Okay, you won't get told the piece of data, you might just get told what they all add up to. So very, very quickly, we are just going to go through some basic mean, median, mode calculations. We'll start with mode. The mode here, this first one, is simply going to be 8, because 8 is the most common number. The median will be 5, because I put all the numbers in order here, and 5 is in the middle. And then you mean, add up the numbers, divide by 7, because there's 7 numbers there, you should get 5.1423 significant figures. And then our next example, well, this data is what we call bimodal, because there's 2 modes. Okay, there's 26 and there's the 32. The median, well, you've got 27 and 29 in the middle. Okay, so the median is just 28 here, because that's halfway between the 2. And you mean, so add up all these numbers, divide by, we add up all numbers, you get 285. Divide that by 10, you get 28.5. So our second example, you've got these temperatures here, and we're going to find the mean and median of this data. So the mean, we add them all up, divide by 7, because there's 7 pieces of data there. So when we do that, we're going to get 21.2 degrees Celsius. The median, so I put all the data in, put all the data in order there, and we find that 16.7 is in the middle. Now this is quite interesting because our mean and median are quite different from one another, and there's a reason for that. It's because of this 47.6. Okay, this 47.6 does seem very strange. So the child's teacher realises that the figure should actually be 17.6, which makes more sense. Okay, 47.6 does seem extremely hot all of a sudden compared to those other temperatures. So if this 17.6, well, this is going to have an impact on the mean. Okay, I'm not going to work this out, but if you make this value smaller, then the numbers will add up to a smaller amount, and you're dividing a smaller number by 7. So the mean will decrease. Okay, so if this 47.6 is actually a 17.6, the mean is actually going to be less. Okay, but the median will stay the same, because this 47.6, well, it's 17.6, but 16.7 will still be in the middle, so the median will stay the same. So really what this has shown us is here as the impact of what a large value can do for the mean. Okay, you can see there that this large value, that 47.6, has made the mean be 21.2. Well, there's only one value that's actually above that, so maybe the mean hasn't been the best, isn't the best average to use here if you've got these extreme values. Whereas you can see the 16.7 sounds like a much more realistic figure for this data, okay, much more representative figure for this data. And we'll talk more about when the mean is better, when the median is better. So example 3, we have 25 observations is the mean of 25 observations is 6.4, and you've got a second sample where the mean is 7.2. Calculate the overall mean of 55 observations. Now, one common mistake I see here is people might just find the mean of the means, but the problem is one mean has more observations in than the other. Okay, so it's not fair to just find the average of the two means. Okay, what we need to do is take consideration the sample size. So if there's 25 observations of 6.4, this means the sum of all values is going to be 25 times 6.4, which is 160. And then we do the 30 times 7.2, which is 260. And then we add those values together to get the overall total. Okay, so what I've done there, essentially done the mean calculation reverse. Normally, I'd add up all the numbers, divide by how many there are, and I get the mean. Now what I'm doing is I'm taking the mean, timesing by how many values there are, and it's telling me what the values add up to altogether. So I do that for both sets of data, get 376. Now what I can do is I know all the values are 376, divide that by 55, and I get 6.84. Okay, which is what we'd expect, because halfway between 6.4 and 7.2 is 6.8, but there's more values in this second sample, so you'd expect the mean to be closer to the 7.2. Okay, so this part, just make sure you take time to read this information. Just to summarise, the mean takes all the values into consideration. Okay, so it's why we often use the mean. But the problem with the mean is it is affected by these extreme values, which we call outliers. So we met one of these in example 2, that you can see that 47.6 had a large impact on the mean. Okay, it made it much higher than it is. Okay, the median, okay, might not use all the data, but it's not affected as much by these outliers. Okay, and then we have the mode, which, to be fair, most of the time isn't that useful, but it is useful when you've got a value that is really frequently involved. Okay, so if there's a value that really has a high frequency compared to all the others, it can be useful. But if you're finding that a lot of the frequencies are the same, it's not gonna be great to use. But it also has an advantage for qualitative data. For example, you can't find the mean and median of qualitative data, but you can find the mode of it. You can find the most frequent value. So in example 4, we've got salaries of employees at a small firm, and then you've got the following salaries there, and you've got the mean, median, mode already calculated for us. Okay, so think about, these values are quite different. Okay, now the mean salary here being 28,800 doesn't seem like it's that representative of the whole company, because only one person earns over the mean salary. Okay, and then the median, you've got 15,000, which seems more better representative in this case. So depending on what your circumstance is, you might argue which one is better. Okay, so for example, if you're the managing director, you might quote the mean. Okay, because it makes it that your company's appearing to pay employees more than it maybe does. Okay, but maybe if you're the union representative, you might quote the median mode, saying this is what the average amount is. It might give you evidence for a pay rise. So it depends on what point of view you're arguing from, which average you might use. Okay, in this way you'll be careful with maybe statistics that you see in the media, maybe in politics, is they're not lying to you, but they're choosing the average that best represents their argument, their case. So what we're going to move on to is finding the measure location from a frequency table. So we're going to find mean, median, mode from a frequency table. yeah, again, if you want to kind of just go through read through this here, you can do. I'm not going to read this out now. I'm just going to go straight into example 5. So we're going to move into example 5, where we're going to find where a record records the shirt collar size X of the male students in a year. The results are given below. So finding the mode of this data that's been put in this group frequency table for us. Well, the mode is simple enough, okay, because it's just the most frequent size shirt, which is just the 16.5, okay, because that has the highest frequency of all, okay. But remember to actually put the actual size of the shirt, don't put the frequency here. Now the median, now we have, if we add up all these values here, our total frequency is 95. So if we want to find the median, well, we add 1 to the number of pieces of data we have, 96, and then we divide that by 2. Later, we will look at, when we do estimations for the mean, that we might not actually add on the 1 first because we're just finding an estimate. But for now, we're just gonna do this. So the median is the 48th value. Okay. So if I've got 95 values, the median is the 48th value. Okay, sorry about my writing here. So the median is 48 values. So it's not going to be a size 15 shirt because there's only 3 of those. Okay, so the first 3 pieces of data would be 15, 15, 15. Okay, if you used to write it all out in order. The next 17 pieces of data would be 15.5, 15.5. So the first 20 pieces of data will not include the 48 value. Then, after writing down these 20 numbers, we're going to write 29 16s now. So this will take us up to 49 pieces of data overall. So the median, therefore, the 48th value will be 16. Okay, because the 48th number, when you write this in a list, is going to be a 16. Okay, as will the 49th number, for example, as well. But we're only looking for the 48th. So the mean is going to be a much more longer calculation. So we've got, what this means in the group table here is we've got 3 15s, we've got 7 15.5s. So I said group table, I should say frequency table. We've got 3 15s, we've got 17 15.5s, 29 16s, and so on. So the long way of doing it would be doing 15 plus 15 plus 15, and then we'd do 15.5 plus 15.5. We do it 17 times. But it's going to be much quicker if we just multiply these 2 columns together. Okay? Because if I add 3 15s together, that's just the same as doing 3 times 15. If I've got 17 15.5s, that's the same as doing 17 times 15 and a half. That should be 6 there. So I'm just going to multiply these groups together. I'm just going to try to do this really quickly. So if you want to check this, you can do. So this is what it all adds up to. Okay. So this is the quick way of adding together all the numbers. So now what I have to do is I add this column together. Okay, so this is what the sum of all values is, 1537.5. So to calculate my mean, I do the sum of all values, and then remember I have to divide by the frequency. Okay, so I divide by how many numbers there are. That is the frequency. That's 95. Okay, sometimes you'll be given this total frequency, sometimes you won't. When I do that, I get 16.18. Okay. Look at your answer. Does it make sense given the data you've got? Yes, it does. Okay. Your mode was 16.5. Your median was 16. Your mean is 16.18. That doesn't sound too realistic. If you're getting a mean that's lower than your lowest number or higher than your highest number, then you need to go back and check it. Final example. Contrary to what this example says, I don't have the boring habit of measuring pine cones, but let's just go through this example. So we're going to find the mode class first. Okay, the mode class is simple enough calculation, not really even calculation. It's just the class that is the most frequent. Okay, so that's just your 34 to 36 millimeter class. Okay, so that is your modal class. The median class Now, if you count the overall frequency, we get 70. Okay, so if you've got 70 values, you're looking for your 35th and 36th value. Okay, so that's just doing, remember, 70 plus 1 is 71 divided by 2, 35.5. So your 35th, 36th value is not going to be in the first row because that's only 2. It's not going to be in your second row. That'll take you up to 27. Okay, it's still not going to be where the 35th and 36th value is. So it's going to be the 34 to 36 class again. Okay, that's where it's going to be. So remember, that's the right class. But remember, if you want to write it as an equality, there's actually between 33.5 and 36.5. So now let's find the frequency. Now, the mean. So the difference here is I don't know what the exact values are. Before I said, okay, well, I've got 2 15s, I've got 5 17s, and it was easy enough to do it that way. But now I don't actually have a value here. So what I have to do is I have to find the midpoint. Okay, so the midpoint of the first category is going to be 30.5. So my estimate that I'm making is every cone in that category was 30.5 millimeters. In the second one, I'm estimating that everyone is going to be 32.5 millimeters, 35 millimeters, and then finally 38 millimeters. Just check the class widths change here, so just be very careful with that. Okay, so this is only an estimate, okay, because I don't know the exact values. I'm just making an estimate what they could be, and using the midpoint's a good estimate because what will happen is reality is you'll have some values at the top of the class interval, some at the bottom, which will cancel out with one another and leave you with the data in the middle. Okay, not to say it's exactly going to work like that, but it's the best estimate that we can come up with. So what this is now saying is I've got 2 cones at the 30.5 millimeters. So what I do in this other column that I'm going to reduce here is I'm going to do frequency times the midpoint, and these are going to be the values that I do. Now just make sure that you're timesing together the correct values. Okay, you're doing the frequency times the midpoint. Just trying to make sure I definitely get the right values here. So 494 to end with. Okay, and then this is the sum of all your values. So you need to add this column up, and we get 2,471.5. So then just do the sum of values divided by your frequency at the end. And when we do that, we get 34.54. Yet again, check that makes sense. Look at your data. Yeah, that makes sense. You know, that is in your modal group and your median class interval. So that does make sense to us. Okay. In the next video, we're going to start looking at measures of spread. And later, we're going to come back to see how we can get a more accurate way of finding an estimate for the median. Instead, at the moment, we're just going to set to find a class interval, but later, we're actually going to find an estimate to give an actual value for the median.